Yeah. All right, now, the math for this is not much more difficult. Okay, let's take number 1 here. We're going to start with 10 moles of methane. We're going to put it over 1. Starting amounts in stoichiometry almost always go over 1. Starting amounts in stoichiometry almost always go over 1. Okay? This is the starting amount that you're given. It might be a starting amount that you're given in an actual lab. It might be a starting amount I'm giving you in a problem, but it's whatever you're given as the starting amount. You have to read the problem and interpret the problem and figure out what the starting amount is. Okay? Now, what I want to do to build a conversion unit here, or this will be a conversion factor, not really a conversion unit, is I want to look at the balanced equation and use the species that matches my starting amount. Well, in this case, the species is CH4. And I can say this is moles of methane, so I can say this is 1 mole of methane in the equation. 1 mole methane.
Why do you say that?
Because this is how I build the molar ratio here for the conversion. All right?
And you know it's 1 mole because it doesn't have enough.
Because it's right, because there's an implied 1 in the equation where there's no 1 written. Okay? And then if I'm trying to find the amount of carbon dioxide, I'm going to look at the coefficient in front of carbon dioxide and put that on the top. I'm going to cancel units of measurement. I'm going to cancel the species that I can cancel and do the math. And I have 10 moles of CO2 produced. Does that make sense? Now you do the same thing for problem number 2 now. You do the same thing for problem number 2. Make sure you have the right molar ratio for problem number 2.
Which number 2?
Right here, number 2. Yeah.
Do we still start with 10 moles? Or no? Do we start?
Yeah, because that's what the question was referring to, the 10 moles up here, right? Okay. Did you put your pass in your personal folder? You did? Was it excused? Not excused?
Are
Okay.
we going to be multiplying across? Or
Hang on 1 second. Oh, here it is. We have that main thing. All right. And how many moles of water do I put on the top?
2?
2 moles of water.
Will it always be combustion or no?
No. It can be any kind of equation. Okay? So I heard somebody ask what kind of mathematical operation you do here. You multiply across what's on the top here. Across the top you multiply. What's on the bottom is division. Well, dividing by 1 gives us the same thing, so we really if you think about it, you really don't have to do division by 1. Right? I mean, if you did, you just get the same answer. And if you do the math correctly, you should get 20 moles of H2O. Does that make sense? All right. These things right here are molar ratios. And they are always built from the coefficients in balanced chemical equations. Okay? Molar ratios are always built from the coefficients in balanced chemical equations.